Hi friends, welcome to Code with Swiggy YouTube channel. So in the previous video, we have discussed about data types. Okay. In this video, we're going to discuss about how to choose a data type based on the value. Okay, because for whole numbers itself, we have 4 different data types, right? So we need to understand that how we need to choose the data type. Okay, fine. So before we get into this video, if you are new to our channel and if you are not aware of what we have discussed till date, so you don't need to worry. We always used to add all the links in the description so that you can go ahead and have a look on the previous videos. So as a recap, so we all know we have two different data types in Java. The one is primitive data type and another one is non-primitive data type. So the primitive data type we are having around 8 data types. In non-primitive we have one, that is string, because string is a class in Java. Okay. So technically all these 8 data types having its wrapper class in Java. Okay. That we will discuss in later part. Okay, fine. So say for example, if it is the byte, then you will have a class called byte. Okay, so these things we will discuss later. Now I don't want to confuse all those things. Okay, so leave this now. Okay, fine. In the previous video we discussed about whole numbers, right? To hold a whole number we have 4 different data types. One is byte, another one is short, another one is integer, another one is long, right? Okay, so based on the value range, okay, so each and every data type which we specified it here, it has its own memory. Okay, say for example, if it is the byte, it will take 1 byte memory. Okay, short 2 byte memory, then integer it will take 4 byte. If it is a long, it will take 8 byte, right? Fine. So based on this memory, we're going to assign the values. Okay. So if it is 1 byte means we will have 8 bits, right? So how we will specify the 8 bits in a binary format? Okay, we all know, right? So it will start from 0, then 1, 2, 3, 4, 5, 6, 7. So now we have 8 bits. Okay. So this how we will represent the bits in binary. Okay, fine. So say for example, if you want to get value for 10, okay, then how we will specify? So first, before that, I will tell you the value for each and everything. 2 power 0 means, so its value of 2 power 0 is 1, 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, 2 power 4 is 16, 2 power 5 is 32, 2 power 6 is 64, 2 power 7 is 128. Okay, fine. If it is 10, then we have to put 1 on 8 and as well as 2. Okay, so if you add 8 and 2, then you will get 10. Okay, the remaining you need to fill it with 0. Okay, at this point maybe give you a little bit confusion. Okay, don't worry, I will explain you how to convert a decimal value to binary. If it is 8 bits, then it will start from 0 to go till 7. Okay, so if it is 16 bit, then it will start from 2 power 0 to, it will go till 2 power 15, right? So if it is integer, then it will start from 0 to, it will go till 2 power 31. So if it is long, it will start from 0 to, it will go till 63. One good thing in Java is we can hold positive and negative numbers in a single data type. There is nothing called signed or unsigned things in Java. So say for example, if you are taking byte, okay, so it will start from minus 2 power 7 value to 0 to 2 power 7 minus 1. That is, mathematically, if you want to say, it will take the value from minus 128 to 127. Okay. The same way, if you take short, now you can easily compute this for short, right? So short is, because byte is 8 bits, okay, short is 16 bit, right? That means 2 byte memory it's gonna take. So what is the value we will get? If it is 16, then if we start from 0, then we will get 15, right? So the minus value will be 2 power minus 15 to 0 to 2 power 15 minus 1. If it is integer, this is 32 bit, right? So 32 bit means we will go from 0 to 31. Okay, so then the value will be minus 2 power 31 to 0, then 0 to 2 power 31 minus 1. Okay, so if it is long, then this is 64 bit. Okay, so if you take from 0, then it will be 63, right? So the value will be minus 2 power 63 to 0 to 2 power 63 minus 1. Okay, fine. If you calculate 2 power 15, okay, then you will get value as minus 32,768 to 32,767, right? Okay, if you calculate for 31, 2 power 31, you will get a value like minus 2147483,648 to positive will be 2147483,647. So you will get a very big number for 2 power 63. Okay, so now I think you may get some idea about what is the value we can hold in the data types. Okay, if you are having a value between minus 128 to plus 127, then you can choose byte as data type. Okay, if your value is greater than 127, then obviously you have to choose short as your data type, right? Because the short will take the value from 32,768 to 32,767. So if you have a value in this range, then you have to choose the data type as short. Okay. The same way, if your value is comes between in this range, okay, then you have to choose the data type as integer. Okay, and if your value is going beyond this limit, then obviously you have to choose long as your data type. Okay, now I think it's more clear to you how we need to choose a data type. Okay, fine. Now we are very much clear that how to choose the data type. Okay, but you have a question like how to convert a decimal value to a binary. Okay, and one more question is why the decimal values are denoted with base 10, why the binary values are denoted with base 2. For example, let's we consider 10 as a decimal number, okay, and the equivalent binary value will be 101, and if you want to specify this binary value into 8-bit format, then the value will go like this, right? Okay, we all know the 8-bit will start from 2 power 0 to 2 power 7. Correct? So What is the value of 2 power 3? It's 8. What is the value of 2 power 1? It's 2. If you add 8 plus 2, we are getting 10, right? Fine. So this is how we will calculate. Okay. If you want to elaborate little bit more, I will explain you in a clear way. Okay. But before that, why we are denoting the decimal value with base 10? Why we are denoting the binary as base 2? Okay. That we need to get it clear, right? Okay. If you consider a decimal, okay, the possible values are from 0 to 9. Okay. So in this case, here we are having 10 numbers. That's the reason the decimal values are denoted with base 10. Okay. If you consider a binary value, the possible values are only two, zeros and ones, right? That's the reason the binary values are denoted with 2. Now we will see how to convert it. Okay. So again, I am going to take 10 as example. This needs to be converted as 10102. Okay, fine. So to convert this, we all know, right? If you want to convert a decimal to binary, obviously you have to divide that number by 2. Okay, because we want base 2. So if you take 10 and if you divide this number by 2, then you will get 5 times you can divide that number, right? The remainder will be 0. Again, if you divide this number by 2, obviously 2 times we can do and we will get the remainder as 1. Again, if you divide it by 2, you will get 1, okay, the remainder as 0. Okay, now we have to go to bottom to top approach to get the value. Okay, so if you write from bottom to top 1 0 1 0, okay, then you will get the same value whatever we have. Okay, so this how we will get a value for binary. So or else you can easily use this concept. Okay, if the value is less than 127, okay, then you have to use 8 bit, that is 2 power 7, 2 power 6, power 5, 2 power 4, 2 power 3, 2 power 2, 2 power 1, 2 power 0. So anything power 0 is 1, 2 power 1 is obviously 2, 2 power 2 is 4, then 2 power 3 is 8, 2 power 4 is 16, 2 power 5 is 32, 2 power 6 is 64, 2 power 7 is 128. Okay, so if you see this number is multiplied by 2, this number is multiplied by 2, and this number is multiplied by 2. The same way we are multiplying it by 2. Now I want to convert a decimal number which is 70. So if you want to get a binary for a 70, so first we have to check. So 64 is here, right? Okay, we have to take the nearest value, okay, and then we have to compute it. Okay, so 70, obviously you cannot go beyond 64, so obviously you have to stick with 64. Okay, then 64, then if you add 32, the value will go beyond 70, so you should not take 32. Then if you take 16, this is also will go beyond 70. If you take 8, this is also will go beyond 70. So if you take 4, 64, okay, I will consider I'm taking this. Okay, if you take this one, obviously you will go beyond the 70. Okay, so I'm marking it as 0. If you take 16, this is also go beyond, we are not taking this value also. If you take 8 also, we will not achieve 70. Okay, fine. If you take 4, okay, obviously 64 plus 4 is 68. Okay, this is coming below 70, so we can mark this one as 1. Okay, now we have 68, so 68 plus 2 will be 70. Okay, then you have to mark this one as 1, the remaining should be 0. Okay, so the equivalent value, binary value for 70 is obviously this also 0. Okay, 0 1 0 0 0 1 1 0. So this how the system will calculate the whatever value we are specifying in a decimal. Okay, say for example, let's consider this 70. If we want to declare it, I think we can go with byte because it's less than 128, right? 127, so we can go with the byte. byte, I can say number equal to 70. So if we specify a number like this, obviously the system will do the above calculation and it will calculate it equivalent binary value. Then this binary value finally given into the machine to calculate. Okay, fine. So this is how whole number computation will happen in our system. Just I want to explain one more time about the ranges and how to choose the data type for a particular value. Okay, example, I am going to take 100 as one input, then 1200 as one input, then 35,432 as one input. Okay, so 100 we know, right? We have four different data types: byte, short, integer, last one is long. Okay, so the byte in the positive side you can go till 127, right? So for this 100 we have to make like private byte n equal to 100. Okay, the same way if you want to make it for 1200, okay, so the 1200 will get fit in the short because the short will take till 32,767, right? So the 1200 will not get fit into the byte, so we have to go for the next one, that is short. Okay, so the short we have to specify like this: private short n equal to 1200. Okay, the last value. Okay, so obviously the short will hold till 32,767. Okay, but our value is above that 32,767, right? So obviously we have to go for integer. Private integer n equal to 35,432. So this how we have to choose data types for our whole numbers. Okay, now I think it's more clear about how to choose the data types. In the next video we will discuss about floating point. Okay, thanks for watching our videos. Please subscribe our channel for more videos like this. Keep supporting us. Thank you.